Okay, so we have to find out the nth term and the square up to n terms of the sequence. So let's see the sequence. It is 1, 5, 13, 29, 61. So we can clearly see that 5 minus 1 is 4, 13 minus 5 is 8, 29 minus 13 is 16, 61 minus 29 is 32. So the difference between the consecutive numbers is basically increasing as a square of 2. So let the nth term be, say, Tn, and this is equal to S. And the general method for solving these problems is we write S again, but we write it one step down. So over here it will be 1 plus 5 plus 13 plus 29, and it will go on till we have plus Tn, and this is equal to S. And the reason for doing that is when we subtract the two sums, then we will get an actual series, and that is 1 plus 4 plus 8 and so on. So over here S minus S is 0, so we will have 0, and here we are left with 1 plus 5 minus 1 is 4, 13 minus 5 is 8, then 16 and so on, and in the end we are just left with minus Tn. Okay, so now 1 plus 4 plus 8 plus 16 and so on, this will be equal to Tn, and we have to find the nth term, right? So if you look at this sequence, then it is 2 square, 2 cube, 2 raised to 4 and so on, and total there will be n minus 1 terms, because we are not including 1 in this, otherwise there would have been n terms, but right now there are n minus 1 terms. So what we do to complete the sequence is we write 1 plus 2 plus 4 plus 8, and this will go on. So we have added a 2, so we will have to subtract a 2, that is equal to Tn. So first we had n minus 1 terms, now we will have only up to here, we will have n plus 1 terms, because we are including 1 and we have added 2, so that is 2 extra terms. And over here we have an obvious sequence. We have a sum of a GP, that is 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 till n minus 1, n plus 1 terms. So this will become 2 raised to n. Okay, and this minus 2 is equal to Tn. Alright, so we know the formula for sum of the GP. It is last term into common ratio minus first term upon common ratio minus 1. So let's just use that. So it will be, last term is 2 raised to n into common ratio, so 2 raised to n into 2, so that will become 2 raised to n plus 1 minus the first term is 1 upon common ratio minus 1, so that is 2 minus 1, this will simply become 1, and this minus 2 is equal to Tn. So basically 2 raised to n plus 1 minus 3 is equal to Tn. So we solved the first part of the problem. Now coming to the second part, we have to find out the summation of this. So basically it is sum of 2 raised to n plus 1 minus 3. N goes from 1 to n. Okay. So again, here we can write, if n is equal to 1, it will be 2 raised to 2, so that is 4 plus 8 plus dot 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 till 2 raised to, we have n plus 1 minus, we will have 3n, right? Because it is n from 1 to n and this will simply become minus 3n. So again, it's a GP, and we know the formula for the sum of a GP. So it is last term into common ratio. So over here it will become 2 raised to n plus 1 plus 1. So that is n plus 2 minus the first term. So that is minus 4 upon, we have common ratio minus 1. So 2 minus 1 minus 3n. So that will become 2 raised to n plus 2 minus 4 minus 3n. So this is the required sum, and this is our final answer. So coming to the second part, we are given the series 1 plus 13 plus 22 plus 33. So the difference over here is 7. 22 minus 13 is 9. Then 11. So we clearly see that the difference of the consecutive terms form an AP. Again, we know how to solve such problems, right? First, let's write Tn. So this is equal to Tn is equal to S. Now to solve such problems, we write the whole thing again, but just one step down. So this will become 6 plus 13 plus 22. And then we are left with plus Tn is equal to S, and then subtract the 2. So on this side we have 0 is equal to, so 6 will remain as it is. Then we have plus 13 minus 6 is 7, then 9, then 11, and it will go on, and then we are left with minus Tn in the end. So Tn is equal to 6 plus 7 plus 9 plus 11. Okay, and over here we have n minus 1 terms because we are not including 6. So it will be n minus 1 terms. But let's just complete this series. We know the terms that should come before 7, right? So let's just write those. So that will be 1 plus 3 plus 5 plus 7 plus 9. Okay. So 5 plus 3, 8, and plus 1, 9. So we are adding 9 to the whole value. So we already had a 6, so we just have to minus 3. And we are adding 3 new terms to n minus 1. So the total number of terms of this series now will be n plus 2. Okay. And Tn is this. So we know the formula for sum of n odd series, right? It is n square. So Tn is equal to n plus 2 the whole square minus 3. So that is our required Tn. Now to write the sum of all of these terms, it will become summation of Tn. N goes from 1 to n. And we already know the value of Tn, right? It is n square. Okay, from here we can calculate it. It is n square plus 4n, and then 4 minus 3 is 1, so it is plus 1. Okay, so it is n square plus 4n plus 1. So this can simply be written as summation of n square from 1 to n plus 4 into summation of n from 1 to n plus, we know that this will be just n. Okay, so we know the formula for this summation of n square from 1 to n. It is n plus 1, 2n plus 1 upon 6. Then the next we have summation of n. We know that it is n n plus 1 upon 2, and then we are left with just plus n. So this will be our final answer for the sum.